Welcome to 3.4, solving problems using acute triangles. Let's begin. All right, there are two angle names to know. The angle of depression means that that's the angle between a horizontal line and the line of sight when looking down at an object. Okay? Depression means you're looking down. So if this guy's standing here, he is looking down at this rock on the ground. This angle, as he looks down, is the angle of depression. Okay? The second type of angle is the angle of elevation. This is the angle between a horizontal line and the line of sight when looking up at an object. Elevation, elevator, elevate, right? Looking up. Okay? So here, angle of elevation is looking up. Angle of depression is looking down. Okay? Give you a moment and then we'll look at the example. We've got 3 or 4 examples to go through together today. And then you'll be ready to write the exam. All right. So here's an example. Let's move this over a bit. 2 security cameras in a museum must be adjusted to monitor a new display of fossils. Cameras are mounted 6 meters above the floor, directly across from each other on opposite walls. The walls are 12 meters apart. The fossils are displayed in cases made of wood and glass. The top is 1.5 meters above the floor. Distance from the left to the center of the top of the display is 4.8 meters. Both cameras must aim at the top of the display. Okay. Again, don't worry about writing down the example, but what I would do is to try and draw. I would try and draw the diagram. Okay, take a minute, draw the diagram, and then we will solve it. That's just the distance from the wall to there. Because if this whole thing is 6 and that's 4.5, it's just this is 1.5. We're not really going to use that. We won't need it. You shouldn't. Now, in the problem-solving questions, there's 3 different ways you can solve questions, right? You could use your basic right angle SOHCAHTOA rules, right? Sine, cosine, tan. You could use the sine law, or you could use the cos law. So now you're going to have to look at the questions, examine what you have, and decide what would be best to solve these questions. Okay? Now, all right. The first thing I'm going to solve for that I see is right here. Okay? I need to find these 2 angles. And I've been given a 90-degree angle, right? So if I've got a 90-degree angle, it's going to be easy to solve for that missing one. So I can draw that triangle separately here for you if you'd like. This is 4.5, the hypotenuse is 4.8. It's a 90-degree angle, and we're trying to find this right here. So here we have opposite and hypotenuse. So I would use sine 4.5 over 4.8 4.5 divided by 4.8. And then second function sine will give me an angle of 69.6 degrees, which will round to 70 degrees. It's like a Greek letter, theta, I think. If you want to use an X or something instead, that's fine. You could call it whatever you want, but it's just a circle with a line through the middle. All right. Now, there's different methods to solve for this angle. Okay. What I think I'm going to try to do is I want to use this right triangle right here. Okay. The only thing I don't know is this 12. This 12 is the whole thing, right? And I just need up to here, right? I don't actually need the entire piece. So the first thing I have to do is I have to find this little piece right here. I'm going to call it X. I can find that using our same triangle we had right here, right? Now we know, let's try that again. We know this is 70 degrees now. We know the hypotenuse is 4.8. We'll call this side X. So adjacent hypotenuse, right, means we can use cos. So I can go cos of 70 equals the adjacent X over the hypotenuse 4.8. The X is on the top, so we're going to multiply those two together. So cos 70 times 4.8. X is 1.64. So if this distance right here is 1.64 and the whole thing is 12 across the top, right? That means that 12 minus 1.64 you go cos 70, you get 0.342 times that by 4.8, and you get 1.64. Remember, you're not using second function cos, you're just using regular cos. All right, so 12 minus 1.64 is 10.36. So this distance right here, I'll use a different color. This distance right here in red, 10.36. So now I have a triangle. I'll draw it for you. That's 10.36. This is 4.5. And the hypotenuse we don't have, but we don't really need it. And we're trying to find this angle right here. I'll call it angle Y. So again, if we have a 90-degree angle, our life is pretty easy. So we just go opposite adjacent is tan. Tan of angle Y is 4.5 over 10.36. 4.5 divided by 10.36 gives you 0.434, etc. Trying to find the angle, so we're going to use tan to the minus 1. We get 23.4 degrees, which we can round to 23 degrees. So our two angles that we need are 70 degrees and 23 degrees. Okay? 4.5 divided by 10.36, you get 0.43436. Second function, tan, 23.478. Did you get that? All right. Okay. So again, I know this question looks difficult when you first look at it because there's a lot of different things happening and the explanation is very long and confusing. But just try to break it down to small triangles, to things you can manage. Okay? All right, I can put this back up after, but I'm going to go on to the next one. Okay, for this one, we are asked to explain how you would determine the indicated angle measure or side length in each triangle. So what I'm looking for here is, you could say something like sine, cos, tan, or sine law, or cos law. Okay? Sure. So for number one, I can't use, the only way I can use the sine, cos, tan ratios, what do I have to be able to use that? What angle do you have to have in your triangle to use that? Right, 90 degrees. Must have 90. If you don't have 90-degree angle, you can't use those, okay? To use the sine law, I need an angle side pair, right? And then to use the cos law is basically everything else. So, do I have a 90-degree angle in the first one? No. So now I look for, do I have an angle side pair? Yes, I do, right here. So I could use that to find the missing angle. So how I could solve this with the sine law, okay, or the law of sine, whatever. In 1b, again, the first thing I look for, do I have a 90-degree angle? Yes, I do. Okay. Then, if I have that, I know opposite, I know adjacent. I could use the tan ratio. You could put, if you just put tan, that would be fine. I would know what you meant. Yeah, you could also use the sine law. That would also be correct. But the easiest one would be to see the 90-degree angle and know it's going to be sine, cos, or tan, right? But yes, you could use the sine law if you found the third angle. Either answer is correct. Okay? And number 3, we don't know any angles. We only know 3 sides. None of them are 90 degrees. So what are we going to use to solve for that missing angle? The cosine law, or the cos law. Right? If you don't know what the missing angles are, if you don't know any angles, then it's the cos law. If you know side, side, side. Okay? All right, next. How many do we have left here? This is the last one. Fred and Agnes are 520 meters apart. As Brendan flies overhead in an airplane, they estimate the angle of elevation of the airplane. Fred, looking south, estimates the angle of elevation to be 60 degrees. Agnes, looking north, estimates it to be 40 degrees. What is the altitude of the airplane to the nearest tenth of a meter? So this is the type of question you could see on an exam, okay? And if you have this question, what's the first thing you're going to do? Draw a triangle. That's right. Okay? Well, you know it's not going to be 90 degrees, right? So I would draw something like this. This would be close enough. Now, we got to start labeling things. They say Fred is looking south, so I'm going to put Fred over here. And Agnes is looking north. She's over here. And Brendan is up in the plane. Okay? So we'll label these three sides A, F, B to go with their names. Okay? Now, the first thing it tells us is that Fred and Agnes are 520 meters apart. So the 520 will go right there, as that's how far apart they are. Fred is looking south. His angle of elevation, so him on the ground looking up, 60 degrees. 60 degrees. Okay? Agnes, looking up at the plane, obviously, her angle of elevation is 40 degrees. The question wants us to find the altitude of the airplane. How high in the air is the airplane? So I'm going to go from Brendan straight down. Eventually, we want to find the height of this plane, okay? Now, we're not going to be able to solve this in one shot. This is going to take 2 equations to be able to do it, okay? So, ignore that middle line for a minute and just look at the triangle as a whole, okay? When I look at the triangle as a whole, I say, how can I solve this? Well, I go angle, side, angle. Angle, side, angle means usually you can use the sine law. Now, we don't currently have an angle side pair, but could we find that third angle? Yes, we could, because we know 2 angles in the triangle, 40 and 60, so I can go 180 minus 60 minus 40. This angle here is 80 degrees. Now, I have an angle side pair, right? I've got an angle of 80 and a side length of 520. So what my plan is here is I want to find one of these missing sides of the triangle, and then once I have that, then I have a right triangle right here that I could use to solve for the height of the airplane. Okay, so I have to do this in two equations. So the first thing I want to find is F over here. Okay, I've got an angle side pair, so I can use the sine law. So what I'm looking for here is 520 over sine 80 equals F over sine 60. Calculator. I'm going to cross multiply and divide. 520 times sine 60 is 450.0 or 0.33. Sine 80 times F is sine 80 F. Then I got to divide both sides by sine 80. So the length of F, rounded to 1 decimal place, is 457.3. So this length right here is 457.3. Now I have a right angle triangle, right? And I'll show you in yellow here. It's right here. There's a 90-degree angle. The hypotenuse is 457. This angle down here is 40. I can use this triangle to find the height. Okay, and I can draw it again for you if you'd like. Oops. .3. This is 40. This is 90 degrees, and I want to find the height. That's opposite and hypotenuse. I'm going to use sine. Sine of 40 equals h over 457.3. 457.3 times 40 sine equals the height. The altitude of Brendan's airplane is 293.9. And that's our answer. No, no. Circle the answer, you're fine. All right, so again, the majority of these questions you're going to work on today are not going to be able to be solved in one shot. You're going to have to do 2 equations to try to figure it out, okay? So these questions are very important to attempt because, yes, I know they are tricky, but they're on the exam and they're worth the most marks, so you want to make sure that you can attempt them. I'll put this page back up in a minute here. Here's your assignment. Actually, I want to give you, these are the textbook questions. Let me give you some workbook ones instead. Page 77. Page 77, 78, 79 in your workbook. All right. This is the end of chapter 3, so your exam will be coming up soon. Thank you. Have a good day.